Okay, so this problem starts us off with right triangle ABC, and we have a couple of things that we know. We know that the length of the hypotenuse BC is equal to little a, and we also know that there is an altitude. There is an altitude with length h. So I'm going to go ahead and draw that altitude in. I'm going to draw that altitude in. Okay, so remember an altitude is one that forms a right angle with whatever side you're referring to. In this case, maybe I'll do that in orange here. And I'm going to label that H. And we know that the hypotenuse BC is subdivided into n equal regions, n equal line segments, where n is some odd number. Okay, so I just chose the smallest odd number that would work, which is 3. Obviously, you could have n equal to 1, but that wouldn't really be much of a problem. Okay, so n equals 3. We might explore the case of n equals 5 just to get us thinking about what this problem actually means. And then alpha is the angle between the middle segment. So that is why n has to be an odd number. Okay, n has to be an odd number so that there is indeed a middle segment. And we essentially want to find the tangent of the angle of just that middle segment and prove that it's equal to this formula, 4nh divided by n squared minus 1 times the hypotenuse BC, which is equal to a. Okay, so this is quite a complicated problem, and maybe there's a way of doing it easier, and at the end of the video I'm going to ask you to come up with an easier way. But right now, the way I see it is that this problem can really be broken into 3 parts. Okay, the first part is just figuring out what tangent of alpha is, and we're going to do that by putting everything in terms of another variable. Okay, so we're going to add another variable into the mix, and then suddenly everything is going to become clear. The second part is going to be to figure out what that variable is in terms of quantities we already know. And then the third part is going to be combining parts 1 and 2 to get our solution. Okay, so what is that variable going to end up being? Well, that variable, to answer this question, is actually going to be the distance between the start of this middle segment right here and this altitude. And the reason for that, the very simple reason, is all of this is right triangle trigonometry, but we're trying to prove the tangent of an angle that is not a right angle is given by something else. And in fact, none of these angles are right angles. But we do know that this is a right angle, which means we have this right triangle right here, this right triangle. It also means we have this right triangle just because of that altitude. We have that right triangle. And of course, we have the big right triangle ABC. We're going to use all of those, but for right now, we're going to call this distance between the start of this middle segment and the altitude, we're going to call that x. So now hopefully everything can become clear. The other thing we're going to need is we're actually going to need a second angle. And that second angle is going to be this one right here. And that is a right triangle. I'm going to call that angle beta. Okay, now I know a couple of things actually. I want to find tangent of alpha, but I know that beta is in a right triangle, and I actually know that alpha plus beta is in a right triangle. Okay, so beta, that's a right triangle, and alpha plus beta is also a right triangle. So my first question would be, is there a way to relate tangent of alpha, tangent of beta, and tangent of alpha plus beta? And the answer is yes. There is a sum formula for tangent, just like there is a sum and difference formula for sine and cosine. I'm going to leave the proof for either another video or for you to look up. But the formula is basically that tangent of alpha plus beta is going to be tangent of alpha plus tangent of beta divided by 1 minus the product. So tangent of alpha times tangent of beta. So you might be wondering yourself, okay, that doesn't help me because I actually want tangent of alpha. by itself. And the algebra can get kind of messy with all these tangents and all these extra letters. So what I'm going to do is I'm going to let tangent of alpha plus beta equals z. And I'm going to let tangent of alpha equal, I can't use x because that was another variable. So maybe r. And we'll let tangent of beta equal maybe s. Really doesn't matter. Okay, but the point is that if z equals r plus s divided by 1 minus r times s, we're trying to solve for tangent of alpha, which is r. So we're just trying to solve for r. So the first step is I would actually multiply by the 1 minus rs. Multiply by the 1 minus rs on both sides. All right, and then I'm going to combine all of the terms with an r. Okay, so I'm going to distribute this z over here. So I get z minus zrs equals r plus s. And then I combine all of the terms with an r to one side of my equation. Since I have a negative over here, I'm going to go and add that over. So we end up getting z minus s equals r plus zrs. And then I can factor the r out, so this is really r times 1 plus zs. Now, if z minus s equals this quantity, I'm going to divide both sides by 1 plus cs. Okay? So then I get that r equals z minus s divided by 1 plus zs. And remember that zr and s just represented tangents of angles, and I only made this substitution so that it was less strenuous to actually do the algebra. Okay, but what we learned from here is that tangent of alpha equals tangent of alpha plus beta minus tangent of beta, all divided by 1 plus the product of tangent of beta and tangent of alpha plus beta. So that's what we learned. Now I'm going to erase some of this algebra because there's really no point in having it. There's no relevance or significance to our problem. Okay, but we know tangent of alpha plus beta and tangent of beta from our problem. And we only know those because of our definition of the variable x as the distance between the start of that middle segment to the hypotenuse. Okay, so let's focus on beta for a second. So we're going to look at this right triangle. But then tangent of beta, by definition, by SOHCAHTOA, that's just the opposite side x divided by the adjacent side h. Okay, so that makes tangent of beta x over h. And tangent of alpha plus beta now we're focusing on this whole angle. So that's a right triangle because this is a right angle. But then tangent of that is what? Let's see, alpha plus beta, yeah. So we have this opposite side divided by the hypotenuse. So we just have to figure out what that is. Okay, well the first step is going to be to figure out what one of these little segments is. That's actually going to be very useful for the next part. So let's go ahead and do that. Let's think about it for a second. If the whole length is A, so if I have segment BC, which looks like this, and I know that the whole thing measures A, and I splice it up into n pieces, that means that each of these pieces has to be A divided by n. So in the simple case that n equals 3, then you would have a over 3 plus a over 3 plus a over 3, which equals a. Imagine that a is just 1. We're talking about a unit segment, and this would be a third plus a third plus a third. Okay, so that means that this actually has to be a divided by n, which is important, because it means now down here, tangent of alpha plus beta is going to be x plus that a over n, all divided by h. Okay, but then we can just plug everything in. So tangent of alpha, according to our formula, is just tangent of alpha plus beta, which is really x plus a over n divided by h. And to be perfectly fair, I should probably do these in different colors. So I'm actually going to redo this in a different color really quickly. So we'll do orange. Okay, minus the tangent of beta, all divided by 1 plus the product of those two things. So 1 plus, and then we had, let's see, divided by h times x over h. I just hope my n's and my h's are clear, because I foresee that being an issue. Okay, but then since we have a common denominator of h, right, h is common right here, that means we can subtract off the x, so x minus x, and then plus this a over n. That's going to become a over n divided by h, divided by, okay, and then this is just what? This is 1 plus that product, which is really x times x plus a over n divided by h squared. Okay, but then some simple algebra and some manipulations, you will ultimately get what? Well, I'm going to actually multiply both sides by h to begin with. And actually, I'm going to multiply both sides by an h squared. So I'm going to take this times h squared. I'm going to take that times h squared. And that's going to get me ah over n, right? I pick up an h, divided by h squared plus x plus a over n. And then the last thing I'm going to do is I'm going to multiply both sides by n now. Okay, so times n. And I finally get my result. I finally get a formula for tangent of alpha, and I get that tangent of alpha is going to be ah divided by nh squared plus, and then this n is going to distribute. Okay, so this portion, I'm going to go ahead and take n times each variable in size. This is x times, and then in parentheses, I'm going to have an nx plus, and then a over n times n is a. So I'm going to pause right there, and this is really part 1 of the solution to this problem. And I'm going to pause there and make sure that you don't have any further questions. And if you do, please pause the video, reflect back on it, do it yourself, do some of the algebra, the intermediary steps, kind of go back. And if you have any questions, feel free to rewind. Okay, but I noticed one thing. I noticed that obviously this is not my correct answer, because my correct answer doesn't have the variable x. So I'm going to be spending the rest of this problem figuring out what the variable x actually is. And the way I'm going to do that is I'm going to set up a bunch of right triangles that will finally circle back and relate x to some complicated formula that you will then algebraically solve to verify my answer for x. Okay, so let's go ahead and get started. This is going to take a couple of drawings and a lot of consideration. Okay, so the first thing that you might notice is that if I want to relate this x to what's actually happening, I might think to include this right triangle, okay? But I actually want all of the sides of the bigger right triangle. And the reason for that is because I know the hypotenuse of the bigger right triangle is A, and that's going to be super easy to work with. So the first right triangle I'm going to consider is this one. Okay, it involves x, and it involves one of these segments. And as long as I can figure out what the length of that segment is, I should be good, all right? So let's go ahead and do that. So I'm going to do it down here. So I'm going to kind of redraw our picture of the right triangle. Okay, so we have this. This is me failing at freehanding this drawing. That was our angle alpha, and we had a altitude h. Okay, so let's just say that altitude was like right here. Okay. That altitude was h. And I wanted to focus in on this side length right here. The reason I want this side length, or the reason that I can easily obtain that side length, is because we know that this entire hypotenuse, which is BC, I know that entire length is A. So I'm actually just going to draw that as a segment because I think that'll be a lot easier to visualize. And now is the point where instead of drawing it into 3 segments, I'm actually going to draw it into 5 segments. And you can draw it in any kind of segments, any number of segments, as long as n is an odd number. Okay, so here I just let n equal 5. And now the goal here is to find this, the length of one of the segments, because that is going to correspond to this entire length. Okay, so how are we going to do that? Well, I know that this middle segment for sure is A over n. One of them has to be A over n. We already determined that. And I know that the whole thing measures A. So I'm actually going to answer a simpler question, and I'm going to find everything that is not this segment A over n. So I'm going to find this and this. Notice that there is symmetry here, because if I take off one of those pieces, I'm basically subtracting one from n, and since n was odd, subtracting one means that this is going to be even. I'm going to have an even number of segments. So if I take A minus A over n, that is going to get me the yellow region. Okay, but you'll notice that the yellow region is very symmetric, like I mentioned, and these are actually of equal lengths. So now I only want the purple segment. Well, the purple one is just 1/2 of the yellow. So I'm now going to just divide this by 2 to only get the yellow segment. Okay. So how can I find just one of these? Actually, I think this was our segment to begin with. Let me just scroll back up. Okay, so yeah, so it starts at the beginning of this middle segment, and we want to start there and go all the way back, because that's how we defined x. So actually we're already done. I didn't need a separate purple segment, my apologies. So we took A, we subtracted one of these segments A over n. Okay, so now we have the yellow region. And then I just divided it by 2 to get our region of interest, which is the orange region. Okay? Now, that region, this is not a right triangle, okay? I actually only want this one, okay, so I apologize earlier for my comment, but what I meant to say was this angle needs to be involved right here, so I need to focus on this right triangle. But really, that's just this entire segment, which we just calculated to be a minus a over n over 2. It's that entire segment minus x, because this segment here was length x. That's our right angle. So this is that length. So I'm going to label this as star. And that's what star is. That's the length of that. Now you have to be absolutely, crucially, importantly careful with calculations like this, because I remember doing it wrong and actually counting wrong, and then I spent an entire day figuring out where I went wrong. So please make sure this makes sense. Okay, so I took out this middle portion, so I have these two. When I subtracted from the total, I cut it in half, and then since that region is starting from the middle portion, which is not a right angle, nothing in here is a right angle, I have to subtract off an x to then finally get a right angle that I'm interested in. Okay, but let's simplify this a little bit more. So I'm actually going to multiply the top and the bottom here by n. So I'm going to take this times n and this times n, and I end up with an minus a over 2n minus x. And then I'm going to factor out that a, so I get a times n minus 1 over 2, n minus x. So that is the length that I'm interested in for my first right triangle. Okay, so the Pythagorean theorem says that star squared, this length right here, which I'm now actually gonna actually denote with this highlighter, star squared plus h squared equals the hypotenuse squared. But the hypotenuse is opposite to the right angle, which is just AB. You might be saying, well, Alex, you're crazy because you don't know AB and you also don't know this star. But we don't have to know AB. We're actually going to relate that to another right triangle in just a second. So don't worry about that. But I'm going to plug in the value of star just so we have it. Okay, so this is actually a n minus 1 all over 2n minus x quantity squared plus h squared, I'm going to leave some room, equals ab squared. Okay, but let's think about this for a second. I have AB of my right triangle. I want to relate that to yet another right triangle. So how am I going to do that? Well, how I'm going to do that is by taking the biggest right triangle. I didn't want to erase that, which is going to be the whole ABC. So this is going to be my next right triangle. And now the Pythagorean theorem says that AB squared plus AC squared equals BC squared. So what I'm going to do is now I'm going to add on both sides of this equation, I'm going to add AC squared. And now you'll notice that on the right-hand side, I have AB squared plus AC squared, which according to the Pythagorean theorem is this hypotenuse squared. But the hypotenuse is A, it's little a. So this side just evaluates to little a squared. Okay, and on the left, I still have my a times n minus 1 all over 2n minus x squared plus h squared, and now I have ac squared equals a squared. So that doesn't look any better because I still have an unknown variable x and I still have an unknown side length ac. But now for our final right triangle, we're going to come full circle, and I need AC to be one of the sides. So let's think about this. How can I involve AC as one of my sides and make sure that I have a right angle? Well, that means that we actually have to use this. Okay, because if this is a right angle, then this also has to be a right angle. Okay, so this is the right triangle that we're now interested in. Because we know this side length is h, and we can find this side length. Okay, so let's do that. I'm actually going to erase this segment and draw it again. Now we're going to come up with a formula for, maybe I'll call it double star. And I'm going to do that formula in red. Be very careful when you're labeling stuff like this. Okay, so just to be absolutely clear, because it doesn't look clear from the picture, this much is what I mean by star, which means that that is going to be my double star. Okay? But that's actually super easy because we already found star, which means double star is just a minus star. I just subtract off this little piece from a, and then that's it. So we actually already did the hard work. Okay, so what was star? I need to remind myself. Star was a times n minus 1 all over 2n minus x. So when I distribute the negative, I'm going to rewrite a as 2n a over 2n. Okay, see the 2n's cancel, and I'm really just writing a in a fancy way. Minus a n minus 1 over 2n plus x. Okay, but then the 2n's combine on the denominator. So I have a 2na, and then when this distributes, I'll have minus 1na. So I'll end up with na minus a over 2n plus x, which when I factor out the a is going to look like this. Okay, go back and verify this for yourself if this doesn't make sense. Okay, so we have this relationship now, which I actually did incorrectly because I went too fast. Okay, so this is a 2na minus a 1na. That's a plus. Okay, so this is just a plus 1. Apologies. Okay. I think everything is in order now. So now if I scroll back here, we actually have AC squared because according to the Pythagorean theorem, I'm now going to add this length to both sides. What do I mean by this length? I mean this length. I'm going to add that to both sides. I'm going to add h squared right? So AC squared plus h squared equals, I'm sorry, no, I said that wrong. The hypotenuse is AC squared, So the hypotenuse, this hypotenuse right here, equals so now I'm going to substitute in what that hypotenuse equals, and I'm going to do it in a different color. So that hypotenuse equals the sum of the side lengths squared. Sum of the squares of the side lengths. So h squared plus double star squared. Equals a squared. Okay, but then finally, plugging in for double star, we get a times n minus 1 over 2n minus x quantities squared. I have two h squareds plus a n plus 1 over 2n plus x quantity squared equals a squared. Now, I want you to stare at that equation and get your weeping out, because I certainly did when I saw it for the first time. But as soon as I finished my box of tissues, I realized something important. All this is a quadratic equation in terms of x. We have a bunch of other complicated variables, but we know all of them. We know n, and we know h, and we know a. Those are given to us in the problem, hypothetically. So all we have to do is kind of expand this out, and you're going to notice that some nice things cancel because of the symmetry of this equation. Okay, so I'm only going to take it to a certain point, and then I'll just kind of give you the solution, but I at least want to walk you through the first couple of steps in how to solve for x. All right, so the first step is going to be, and I'm going to do this all in, how about a mellow blue? Mellow blue for all this junk. Okay, so I'm actually going to kind of FOIL this out. I'm going to distribute. So I'm going to take my first term squared minus 2 times the product of the first and the second term plus my last term squared. And I'm actually going to, so this is the term in blue. I'm trying to think how I should do this. I'm going to move the 2h squared over. Okay, so I'm going to move this over, so I'm going to subtract that from both sides. So then I can only just focus on the blue term. So I'll do that one in a light blue, and I'll do this one in a darker blue. Plus a squared n plus 1 squared over 4n squared plus 2 times the product, that term, and x, plus x squared equals a squared minus 2h squared. Okay, deep breath, because we're getting there. I know it doesn't seem like it, but I promise we are getting somewhere. Okay, I'm going to do this next line in red to kind of combine everything together. Okay. So the first thing I'm going to do is I'm going to cancel this 2 and this 2. And then I'm actually going to make sure to multiply by a 4n on top and bottom. Okay, so I want to make sure that a 4n is on top and bottom. So we'll just take that times 4n, that times 4n, because I want these to have a common denominator. Actually, no, I changed my mind. But I will cancel the 2's out, and I'll cancel the 2's out here as well. But the reason that I'm changing my mind is because I want to actually combine all the terms with an x and keep those separately. Okay, so that would be this term right here and this term right here. So I want to keep those separate. Okay. So instead what I'm going to combine is I'm going to combine this term and this term. So that's going to get me, since they both have a 4n squared, I'm going to get a squared n minus 1 squared plus a squared n plus 1 squared. Don't know why I put that in parentheses. All over 4n squared. Now I'm going to add my highlighted terms. Okay, so I'm going to do this one first since it has a plus sign. So plus a n plus 1x minus a n minus 1x all over n. Okay, so that's my highlighted terms. Next, I have two x squareds. 2x squareds, and that's going to equal a squared minus 2h squared. All right, and I will do some final simplification here. Let's see. If you work this out, well, okay. Let me do it like this. I'm going to simplify this term and kind of leave the rest up to you. This video is already getting pretty long and we're kind of missing the whole point of this. Okay, so if I factor out the ax, I get n plus 1 minus n minus 1. So then I pick up a 2 divided by n. Okay, plus 2x squared equals a squared minus 2h squared. Now, here's what I'm going to do. This junk can move to the other side because I don't care about it. And furthermore, I'm going to divide, ultimately I'm going to divide everything by 2. Okay, because I need this to be a 1x squared. Okay. So I'm going to have, when you do this, you're going to end up with this. You're going to end up with a squared over 2 minus h squared minus that equals x squared, because I divided everything by 2, plus ax over n. Okay, now I can take a deep breath and realize that this is a quadratic, and the best way to approach this quadratic, I'm just going to tell you, is to complete the square. So the thing you're going to add to both sides is going to be half of that squared, which is a over 2n squared. After you complete the square, you can then factor, you can then take a square root. You're only going to be concerned with the positive solution, and then you'll subtract off one thing. And after all of that, you will finally get the x. Okay, you will finally get the x is equal to the square root of n squared times a squared minus 4h squared minus a, all divided by 2n. The reason I'm not going through the algebra is because I'm trying to keep this video as short as possible, and it's already probably very long. I can show it in a separate video, but you can kind of treat it as an exercise. I'm not trying to be one of those math professors that just says, okay, this is an exercise, but I genuinely believe that if you've seen this video up to this point, you should be able to kind of complete the algebra and go to here. So this is what we get for x. Now we're done, basically. We just have a lot more algebra left to do. Because if we go all the way back up to here, not here, but we realize that tangent of alpha is just ah divided by nh squared plus x times nx plus a. So all we need to do is plug in for x and we're done. Okay, well to do that, I just want to remind ourselves, and I'll do it in green to keep colors consistent. But remember that tangent of alpha was, let's see, what was tangent of alpha? AH divided by nh squared plus x times nx plus a. All right, so we're going to treat this in a series of steps. The first step is going to be, since we have x, we're going to take n times x plus a. So we're only concerned with this part of our formula for now. Okay, so what is nx plus a? Well, if you take x times n, that is going to cancel with this n right here, and we're going to get the square root of n squared times a squared minus 4h squared. Okay, and then minus a, all over 2 plus an a, which can be written as 2a over 2. Okay, but then this is the square root of n squared times a squared minus 4h squared plus a. Okay, so that is nx plus a. The next part of our formula, okay, so this is just this part. The next part of our formula takes that times an x. Okay, so that's not too bad. So x times nx plus a is just simply this quantity, which I should put in parentheses, times this quantity. Okay, so the original x was actually a 2n. Okay, so that's important that this has a 2n and this just has a 2. And it's important that these have different signs, because that means that multiplying them is actually pretty easy. And we get what? We get the square root cancels, and we just get a difference of 2 squares. This is n squared a squared minus 4h squared, done, minus a squared, all divided by 4n. Okay, so again, just a series of steps right now. So the next part is then to add an nh squared. Okay, so this orange thing, well, it's about to be orange, is where we're at so far. Next step is then to add nh squared to this. So I'm running out of colors, to be honest, but we're going to do this in kind of some gray. So I'm going to take nh squared plus everything we just did. So that's going to be, I'm going to multiply top and bottom by 4n, which I'm allowed to do, and then plus everything that is highlighted in orange. Okay, which is going to end up being what? Well, this is 4n squared h squared for my first term, this term. And then I'm going to go ahead and distribute the n squared to both of these. So I get n squared a squared minus 4n squared h squared minus a squared. I know this looks bad, but it's actually beautiful because these cancel. Oh no. And we can factor out the a squared, and we get n squared minus 1, and then this is all divided by 4n. Okay, so that is going to be that portion. Okay, so we're almost done. I promise this time, okay? Because all we have to do now is take AH divided by that junk and simplify. So, what should I do my final triumph in? Kind of feeling pink, or maybe this color, whatever this color is. So I'm going to take now tangent of alpha, the whole thing is now AH divided by all the stuff that is in green highlight. This a squared, n squared minus 1 all over 4n. Okay? But that's the same thing as this flipping up top. So that's going to be a 4NAH divided by a squared, n squared minus 1. But then you have a factor of a that cancels, and you're left with the final solution of 4NH divided by n squared minus 1 times an A. If anyone has an easier way of doing this problem, please, I beg of you, let me know in the comments. But otherwise, I think I'm done.